You know, for decades, astronomers looked deep into the heart of this nearby dwarf galaxy, and they thought they knew exactly what they were seeing. A brilliant, dense star cluster right there, acting as its core. But as our tools got sharper, well, the picture got a whole lot stranger. All right, let's dive into this cosmic detective story. So what you're looking at here is Messier 54, or M54 for short. It is one of the brightest, most massive globular clusters we know of. And for the longest time, we just assumed it was the nucleus of the Sagittarius dwarf galaxy. I mean, it's in the right place, it totally looks the part, but a series of cosmic clues would eventually reveal that this was a huge case of mistaken identity. Okay, so to really get to the bottom of this mystery, we first need to meet our two main players. On one side, you've got the Sagittarius dwarf galaxy itself, and on the other, this brilliant star cluster that really looked like its heart, Messier 54. Now, the setting for our story is pretty dramatic. We're talking about galactic cannibalism. About 86,000 light-years away, the Sagittarius dwarf galaxy, we'll call it SGR, is literally being torn apart and devoured by our own Milky Way. And right in the middle of this whole cosmic smash-up, seemingly at the very center of SGR, is M54. So what exactly is M54? It's what we call a globular cluster. Just think of it like a giant, tightly packed, ancient city of stars. These are some of the oldest stellar populations in the universe, all bound together by gravity, and they usually just orbit the core of a much larger galaxy. So the crucial point here is its really unique position. As one research paper beautifully put it, it's kind of like a Chinese box game. You've got M54, a cluster, inside the SGR galaxy, which is itself inside the Milky Way's halo. This nested setup made it this perfect natural laboratory, but it also made it incredibly difficult to tell where the cluster ended and the galaxy's nucleus actually began. All right, so the first real crack in the case came from chemistry. It turns out that stars, a lot like people, have these unique signatures. And the signatures of M54 stars, well, they didn't quite match up with those of their supposed galactic home. You see, stars that are born from the same original cloud of gas, they all share a very distinct chemical makeup. We can actually see this when we analyze their light. We look at the ratio of certain elements, like sodium and oxygen. It's almost like a unique chemical DNA for that specific star cluster. And here it is. This is the key discrepancy. The stars in M54 show what's called a sodium-oxygen anticorrelation. It's a very specific chemical pattern that is a classic textbook signature of a globular cluster. But when astronomers looked at the stars in the surrounding Sagittarius nucleus, that signature was completely gone. They were two chemically distinct populations, plain and simple. So this raised a really fundamental question, right? How could M54 possibly be the core of the SGR galaxy if its stars were made of different stuff than the galaxy's own stars? It was the very first hint that something was really not right with this picture. The next clue only deepened the mystery, and it suggested that maybe our view from Earth was playing a trick on us. And it all came from trying to measure exactly how far away everything was. To measure these insane cosmic distances, astronomers use incredibly powerful tools like the Hubble Space Telescope to create these charts called color magnitude diagrams. Basically, by plotting the brightness and color of thousands of stars, they can figure out how far away a whole population of stars is with incredible precision. And this is where the puzzle got really interesting. A 2011 study using Hubble data found a pretty shocking result. M54 appeared to be about 2 kiloparsecs. That's over 6,500 light-years in front of the main body of the Sagittarius galaxy. The implication here was kind of wild. Was this whole thing just a massive cosmic coincidence? A chance alignment where a totally separate globular cluster in the foreground just happened to line up perfectly with the center of a background galaxy, all from our very specific point of view on Earth? It seemed really unlikely. But that's where the evidence was pointing. So for years, the case just remained open. Was it a real offset or maybe a measurement error? The answer, it turned out, required a revolutionary new perspective on the stars, and it came from the Gaia satellite. The Gaia mission is an absolute game changer. It's in the process of mapping the precise positions, motions, and distances of over 1 billion stars. This gave astronomers not just a flat 2D picture, but a 5D map, so position on the sky, distance, and velocity, allowing them to untangle overlapping objects like they never ever could before. Okay, so let's look at what this data actually revealed. Using Gaia's info on how all the stars are moving, scientists could finally filter the two populations. On the left, you see this jumble of stars that belong to Sagittarius. But on the right, by isolating only the stars that are moving with M54, the cluster just pops out, clear as day, and clearly separate from the galaxy's true center. For the first time, they could actually see the two as distinct entities. And the numbers confirmed what their eyes could now see. The Gaia data revealed a definitive, projected physical separation. This was not a line-of-sight illusion. The galaxy's heart was truly not in the center of its body. It was offset. And just to seal the deal, they weren't just offset in space, they were moving differently too. Now, a velocity difference of 4.1 kilometers per second might not sound like much on a cosmic scale, but it was the final nail in the coffin. Case closed. M54 is not the nucleus of Sagittarius. They are two completely distinct objects just caught in this incredibly complex gravitational dance. So, the mystery is solved. But, in science, every answer just leads to bigger, more profound questions. And proving M54's offset wasn't really an ending. It was the key to unlocking a much, much deeper puzzle about the entire universe. So here's the crucial insight. This offset gives us a perfect real-world laboratory to test our theories about dark matter. And you might ask, why? Well, because the precise way M54 is orbiting through Sagittarius depends entirely on the distribution of that invisible dark matter within the galaxy. So this slide shows the two big competing theories. The standard model, which we call cold dark matter, predicts that galaxies should have this really dense cusp of dark matter right at their core. Now, if that were true, an object like M54 should have sunk to the very center a long, long time ago. But alternative theories suggest a flatter core. In that scenario, M54 wouldn't sink all the way. Instead, it would stall and just kind of oscillate or wobble around the center. So this all builds into a simple but really powerful chain of logic. First, the offset we now observe is direct proof that M54 is not sitting still. It's wobbling. Second, simulations show that this wobble is exactly what you'd expect to see in a galaxy with a cored dark matter halo. Which means, third, this real-world observation directly challenges the standard cuspy model of dark matter. And this brings us to our final, kind of mind-bending thought. A decades-long investigation into what just looked like a simple star cluster has led us all the way here. A small measured offset, just a tiny fraction of a galaxy size, is now providing one of the strongest pieces of evidence yet that our fundamental understanding of dark matter might just be wrong. It's a powerful reminder that sometimes the biggest cosmic truths are hidden in the smallest details.